Good evening, ladies and gentlemen. Thank you for giving me a screen. My name is Gawel Solosky from Bengal University. I have a big favor to show you the recent achievements of Professor Blake Simmons with lignin decomposition. Lignin is very troublesome part of plant waste because, as you see, plant waste consists much from lignocellulose, which is the complex material built from three polymers: lignin, hemicellulose, and cellulose. For processing in the biological way, chemical composition for fuels, lignin is the biggest inhibitor in trouble. Therefore, we seek many potential pathways to remove. Professor Simmons from University University of Los Angeles. He developed method using of lignin removal firstly by the composition of using bacteria, anaerobic bacteria, which firstly we put into this the bacteria put into the action of this bacteria, which are also anaerobic bacteria coming from group of fungi and bacteria from Pyromyces, as this is anaerobic kind of, especially the biggest fungi, which are microbials, are Calimostigomycetes, are bacteria of that are just function as fungi type, so are similar to Aspergillus and Trichoderma, that are earlier found in one of the volcano of California, of Yellowstone bacteria that can, after some condition, after temperature or room temperature, can digest this lignin from wood. And these fungi who are close to bacteria, so are between bacteria and fungi type. So this called is the method is fungal bacteria, which is quite small but requires little energy. So if we have not required rapid decomposition is one. The Professor Simmons was chosen three substrates: sorghum, switchgrass, and poplar. This is the kind of tree, and in anaerobic condition it put this fungi. These fungi were developing, and they observed this by searching by using then acid soluble lignin determination. They found how much lignin was eaten by this bacteria, and the growth of time was similar up to growing up to 400 hours. As the result, were producing bacteria some lactate and acetate and succinate, which make possible potential from this as a result of potential for this bacteria in case of pharmaceutical nutrients. And then we developed that some so the in this case of poplar was slightly, but in case of switchgrass was the highest. So in case of switchgrass, it was a solution for most important, and this was growing and developed on this compound such digested was easily to separate and then change and transfer into three compounds from lignin: vanillic acid, ferulic acid, and proteic acid, and syringic acid, which can be used in and even salicylic acid. So these compounds can be used then for cosmetics and pharmaceuticals and some nutrients. So this is better to and lignin solve. So the rest was cellulose or hemicellulose that can be then digested by bacterial methods like anaerobic digestion or organs. So these methods helps us to process early pre-treatment of method without high energy or without using of chemical agents which are corrosive materials. So this is quite cheap, however, long-term method. The method will is in progress, and hopefully I will look on this method. So seek on Simon's publication, and this helps is big evolution development because it helps because probably will be this bacteria futurely modified and higher this fungi bacteria, because this is strange because these are fungi, but these fungi are classified as fungi, but are also can be classified as microbial, and these this can be also used to produce some in some ether, and this is still genome is not very well found, is developing, and can be better production of this bacteriophagi is better in little alkaline conditions, so on pH of 8, and this helps in cultivation, So, so the conditions are further, and this promising method to develop some energy and economical and maybe is methods of digestion of lignin, which is the bone and then better feed for biological decomposition both in biogas plant and sewage management plant. So I think this this helps in further developing ecological more sustainable methods. Thank you very much.
फिर मैं स्टार्ट करूँ?